So now when we say about the concept of the pressure diagram, the total pressure as well as the center of pressures can always be calculated for any surface which is submerged in a static mass of a liquid, either it is vertical or inclined, by drawing a pressure diagram. So what is this pressure diagram? So a pressure diagram is nothing but a graphical representations of the pressure intensities, that is because as depth increases, the pressure intensity also increases. So if you can plot the variations of this pressure intensity over the surface, this graphical representation is known as the pressure diagrams. This can be plotted to a convenient scales. The pressure intensities can be plotted on a convenient scale at various points on the surface. And since you know that the pressure force is normal to the surface, so therefore the pressure intensity diagram is also normal to the surface. So I will show you the various pressure diagrams which can be plotted for horizontal, vertical and inclined surfaces. So here is an example of three surfaces, which are, one is horizontal, other is vertical, and the last is the inclined plane surface. So now you have a free surface. Now I have an horizontal plane surface which is at depth h. So you know that the pressure intensity is omega into h. So at any point on the horizontal surface, h remains the same. So therefore the variations of pressure intensity omega h will be a constant. Therefore it is a uniform pressure diagram, so it is shown here. So now you can know that this is the pressure intensity. So average pressure intensity into the area of the horizontal plane surface will give you the total pressure force. Similarly, we have a vertical plane surface. Say the top edge is at a depth h1 and the bottom edge is at a depth h2. So now you should know that it is immersed vertically. So what is the pressure intensity at the top? So since it is at depth h1, it will be omega into h1. Similarly, the pressure intensity at depth h2 will be omega into h2. So therefore, it is a trapezoidal diagram. So this is how you plot the pressure intensities over the surface, and which is known as a pressure diagram here. So now you can consider an inclined surface, which is say maybe at an angle theta with respect to horizontal. Again, we are for calculating pressure intensity, you should know the vertical depth. So therefore, the vertical depth, say to the top edge is h1 and to the bottom is h2. So therefore, the pressure intensity at the top edge will be omega into h1 and at the bottom it will be omega into h2. Again, the pressure intensity diagram should be normal to the surface, which is shown here. So, okay, so this is how the pressure intensities are shown, and therefore the pressure diagrams are plotted. So if any problem if you take, you will be able to plot this pressure diagrams. So we will make use of these pressure diagrams in solving problems. So I will show you one problem which with the concept of pressure diagram, the problems will be very easy. So I will take a problem such that, like something like this: a cubical box of size 2 meters by 2 meters by 2 meters contains water up to depth of 1 meters, that is in the bottom portion, and the remaining upper portion is filled with oil of specific gravity 0.8. We have to find the magnitude of total pressure forces on one side of the box and the position of the center of pressures. Here you can note that there are two liquids. So if I had gone for the earlier method of finding out F is equal to omega x bar and using the formulas for H bar is equal to x bar plus Ig by x bar, the problem would be quite difficult. But however, I will show you how to calculate by that method, and then I will prove that by using pressure diagrams this problem can be solved very easily. Just to make you aware that by using the formulas which we had done earlier in the case of the vertical plane surface and inclined plane surface, should we go ahead with such formulas like that conventional methods, or shall we go for a concept of pressure diagram? So after the end of this session, you will come to know that for such type of problems it is better always to use the concept of pressure diagram. So now here it is given as the oil is of specific gravity 0.8. So therefore you will be able to find out specific weight of oil, which is 0.8 into 9.81, which gives 7.848 kilonewton per meter cube. You know that specific weight of water is 9.81 kilonewton per meter cube, and we have the depth of water in the bottom portion as 1 meter and depth of oil in the top portion is 1 meter. So here the width of the box that is perpendicular to the screen is 2 meters. So that is given. So it is 2 meter by 2 meter, okay, by 2 meters. So this is the sketch. So you know that for bottom 1 meter it is water, for the top 1 meter it is oil. So okay, so now we have to find out the total pressure force on the face AB as well as BC. AB face will be 1 meter by 2 meters, and similarly BC will be 1 meter by 2 meters. So in order to calculate by your earlier method, that is how to calculate the force F1 due to oil on face AB, you know that it is omega AX bar. So what is specific weight here? So specific weight of oil is 7.848. So 7.84, area is 1 into 2. So and CG distance of that area is 0.5 meters. So therefore it should be 7.848 into 2 meter square into 0.5, which gives 7.848 kilonewtons. So this force F1 will be acting not at the CG of the surface. You know that it is always acting at the center of pressure. So therefore you will be able to calculate H1 bar for this, so which I will show you later on. So right now I will tell you how to find out the total pressure force. So next is that since in order to find out the force F2 on BC, and there is a free surface at A, but since the superimposed liquid is oil, whereas the bottom liquid is water, so in order to use the formula omega AX bar, you should have one common liquid. So therefore what is done is that the oil depth is converted into equivalent water depth by multiplying by its specific gravity, that is 1 into 0.8, which is 0.8. So therefore a imaginary liquid surface will be at a distance 1.8 above the base of the tank. So in order to calculate force F2 on PC, you should take imaginary liquid surface. So therefore now force F2 on due to water, here it is not oil, it is due to water on face AB. Okay, so this is that will be 0.8 plus 0.5, so it will be 1.3. So therefore it should be 9.81 into 2 into 1.3, so which gives 25.506 kilonewtons. So therefore the total pressure force F1 which is acting on face AB is 7.848 due to oil, and force F2 due to water it is. So this is not oil, so this is water. Okay, on face BC is 25.506. So therefore the total pressure F is F1 plus F2, which gives 33.354 kilonewtons. So that is how you find out. So such complications is involved. So unless you convert into ILS, that is the imaginary liquid surface, you cannot solve the problem. So if in order to use this formula, there should be one common liquid and a free surface of that particular liquid. So then only you will be able to find out the total pressure force. So let me calculate what is the position of F1 and position of F2 in the next slide. So in this case, this is the same diagram. I have converted now force F1 due to oil on face AB, which I told you earlier was 7.848. That is specific weight into area into CG distance, which will give us 7.848 kilonewtons. I converted into an imaginary liquid surface, that is equivalent depth of water, which was 0.8 meters. So now I will be able to find out the force. This force due to water on face AB. Okay, so which will give me 9.81 into 2 into 1.3, because CG of BC is 0.5 meters plus 0.8 is 1.3, so that gives 25.506. So therefore the total pressure force as determined is 33.354 kilonewtons. Now let me find out H1 bar. So how to find out the position of force F1? So that is x bar plus Ig by Ax bar. So what is x bar here for the phase AB? That is due to oil. Force F1 is due to oil. So therefore entire depth of 1 meter is taken. So x bar is 0.5 meters. So 0.5 meters plus. So here it is 2 into, so 1 cube. Okay, so 2 into 1 cube, BD cube by 12. So 2 into 1 cube. So 2 into 1 cube by 12. Area is 2 into 1 and x bar is 0.5. So that gives 0.667. So similarly now I want to find out H2 bar, that is for CG. Okay, that the position of F2 from the free surface. Here for the water, the free surface will become now ILS, that is imaginary liquid surface. I will get the H2 bar from ILS. So therefore H2 bar will be again, so 0.8 plus 0.5, which is 1.3, plus BD cube by 12, which is 2 into, so this is BD cube. Okay, so area is 2 into 1, so x bar is 1.3, which gives 1.364 meters. So now I want to find out the position of F, okay, from this surface, say for example from this surface. So now I have determined, so CG is here, so therefore I got F1. So similarly CG is here, so I will get somewhere here F2. So this is F1, and this is F2. So for F1 this was H1, this was H1 bar, and for F2 this was H2 bar. So now I need the position of F from this surface. So I shall let me calculate from this surface. So take moments about this moment about the top surface, that is the oil surface. So the moment of resultant is equal to moment of the components about the same surface. So therefore F is 33.354 multiplied by H bar should be equal to F1 is 7.848 into H1 bar, which is 0.667, plus F2, which is 33.3 25.506 into distance. H2 bar was something like 1.364. Another 0.2 will be here for this surface. From imaginary surface to the top surface is 0.2. So you add 0.2 to that, so you will get 1.564. So if you solve this, you will get H bar as 1.352 meters from the top surface. So this much procedure is involved when you try to use the formulas, and you have to convert into the imaginary liquid surface to solve a problem. So this is how, when you follow the methods that we did for the vertical surface and inclined surface, you have to do this procedure when there are two types of liquids. But when there is one liquid, it will be very easy, that I have already solved. So now we'll make use of the pressure diagrams, and will not use all these formulas, but we'll make use of the pressure diagrams to solve the same problem, and I will get you the same answer, like total pressure force is 33.354 kilonewtons, whereas H bar is 1.352 meters. So now you concentrate on these values, so whether I will get the same answer or not, and then you decide which method you have to use. So the same problem is taken. So the specific weight of oil is 7.848 kiloton per meter cube. Specific weight of water is 9.81 kiloton per meter cube. So this was the so now so in here, this is the diagram which you have. So now here you know that the pressure intensity at A is 0. So as you move downwards, pressure intensity increases. So therefore the pressure intensity at B is that is 9 here specific weight is 7.848. So 7.848 into 1, so which gives 7.848 kilonewton per meter. So the BC value is now 7.848. So now what is the value of pressure intensity at D? So that means that will be, it is pressure intensity at B, which was 7.848, plus the increase due to water. So that will be nothing but, because the depth of water is 1 meter, so it is 9.81 into 1. So therefore the additional pressure intensity EF will be equal to 9.81 into 1. So that means if you divide into suitable diagrams here, so you will get one triangular diagram ABC, because BC is intensity 7.848, which was that is omega into H. And similarly after C, then because as we move downwards to the bottom, the pressure intensity increases due to water of 1 meter depth, so it's your additional pressure will be 9.81 into 1. So EF will be 9.81. So now you can have three diagrams of ABC, CBDE and CEF. So therefore and then let the forces be F1, F2, F3 due to each of these diagrams. So here, in order to calculate F1, so you should take simply area of this diagram ABC and multiply by the width, or it is also pressure intensity, the average pressure intensity, the 0 and 7.848 divided by 2 into the area. Area is 1 meter into 2. So like this, or it will be for rectangular surfaces there, it will be very easy to write. So therefore you take area of pressure diagram and multiply by the width. So then you will get F1, F2, F3 and add this, and you should get the answer which I got in the earlier case. So this will be so easy to solve the problems. So that's why we are going ahead with the concept of pressure diagrams. So now the same diagram is written once again. So now I want to calculate pressure force F1. It is the area of pressure diagram ABC and multiply by the width which is perpendicular to the screen, which is 2 meters. So half BC is 7.848 into 1 is AB. Multiply by 2 meters is for the width of the tank. So that gives 7.848 kiloliters. Similarly, if I want F2, then I should take area of BCDE, which is like 1 meter is the depth, and this BD is 1 meter and BC is 7.848. So if you multiply by 2, then you will get F2. So therefore area of pressure diagram, which is 7.848 into 1, multiply by 2, that gives 15.696 kilonewtons. Similarly, if I want pressure force F3, then I have to take area of pressure diagram, that is EF is 9.81, so it is half 9.81 into 1 to multiply by 2 to get the total force 9.81. So if I add F1, F2, F3, you will get the answer. So therefore by adding F1, F2, F3, I get the same answer which I had done. So this is so easy to get the total pressure force 33.354 kilonewtons. So when I want to find out the distance of F from the top surface. So now, so here if I know the lever arms for F1, F2 and F3. So what is the lever arm for F1? It should be, because F1, F2 and F3 will act at the CG of those diagrams. If F1 will act at the CG of ABC, F2 will act at CG of BCDE, and CEF will act at CG of the F3 will act at the CG of those diagrams. So what is the lever arm for F1? It will be 2/3 of 1. So what is the lever arm for F2? It will be 1 plus 0.5, 1.5. And for lever arm for F3 is 1 plus 2/3 of 1. So let F act at a distance h bar. So therefore, taking moments about the top, so h1, now we know the calculations. So distance of F1 from top, h1 is 0.67 because it is 2/3 of 1. Similarly, F2 from the top is 1 plus 0.5, 1.5 meters, and F3 from top is H3, that is 1 plus 2/3 of 1, which is 1.67. So now I take moments. So therefore that is, I told you that F into H bar should be equal to F1 into H1 plus F2 into H2 plus F3 into H3. So therefore solving for H bar will get 1.35 meters. So therefore F will act at a distance 1.35 meters from the top surface. This is the same answer that we had determined by the earlier method also. But now when you compare these two methods, you will come to know that the concept of pressure diagrams becomes very simple. So only you are using the concept pressure intensity is omega into H, but only thing is that you should know how to plot the pressure diagrams. So you could divide the pressure diagrams into suitable portions and find out the area of each of the diagram and multiply by the width. You will get the forces F1, F2 and F3. So by taking moments, but you should note that F1, F2, F3 is acting at the CG of those diagrams. So you have to put those forces at the CG of those diagrams, and then take moments. That is by Wagnan's theorem, moment of resultant force, that is 33.354 about the free surface is equal to moment of F1, F2, F3 about the top surface only. So then you will be able to solve